For the third and final video on section 4.4, I would like you to try out numbers 4 and 5 on your own. So please pause the video, work through the proofs, and once you're ready to compare your answers with mine, please hit play. There may be more than one way to approach this proof, there probably is, but I'm going to go over the way that I went about this proof. So for this, I recognize that since angles 1 and 2 are congruent, we can get the sides opposite those angles congruent. So segments AF and FC in that triangle AFC. Because if two angles of a triangle are congruent, then the sides opposite those angles are also congruent. Then I worked with the perpendicular segments that we were given, and I listed the right angles that we got from those. So we know that angles FAD and FCD are right angles because if two segments are perpendicular, then they form a right angle. From there, I recognized that triangles FAD and FCD could be proven congruent by HL. So I used reflexive property on segment FD for the hypotenuses of those triangles, and then we already had the legs FA and FC congruent from step 2. So I said that the two triangles FAD and FCD are congruent by HL. Now, in the end, we want to prove two segments AB and BC congruent. So if we can get a perpendicular bisector, we'll be in pretty good shape. Well, we know that F was already equidistant from the endpoints A and C. But using CPCTC, we can say that segments AD and DC are congruent, which would then make the blue point D also equidistant from the endpoints of the segment, AC. So if we connect the blue and red dots, we get that BD is the perpendicular bisector of AC. And since that orange point B lies on the perpendicular bisector, then it must also be equidistant from the endpoints of the segment, or those yellow points, which would then result in those two segments being congruent, segments AB and BC, because if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. Taking a look at example 5, we were given a perpendicular bisector to begin with in this problem, so I'd be thinking about some points that lie on it. So I first recognize that red point E lies on the perpendicular bisector BD, so it's equidistant from the endpoints of that segment, so those yellow points A and C, which means that segments AE and EC are congruent. Because if we're given a point on the perpendicular bisector, then it is equidistant from the endpoints of the segment. Same thing goes for point B. It's also equidistant from A and C. So that means that segments AB and BC are congruent. From there, I recognize that those top two triangles, BEA and BEC, could be proven congruent by side, side, side after we use the reflexive property on segment BE, and then we can get those two angles congruent by CPCTC. Keep in mind that these equidistance theorems do get a little tricky at times, so make sure if you have any questions that you're asking them right away.